Hey friends, today we will discuss about ring theory. I have decided that in this video with the theory lectures of ring theory, I also try to solve some problems of Dummit and Foote. Okay, so that you can get an idea of how to approach the problems. क्योंकि क्या होता है कि students maximum time YouTube videos देखकर theory lectures तो पढ़ लेते हैं, लेकिन they don't try to solve problems. And mathematics is not only about reading theories and memorize them, rather than solving them. Okay, so I will decide that I will also discuss some more problems, or at least I will give you some idea how to approach those problems. Okay, बाकी आप खुद भी try कर लेना. So today I will discuss about the ring theory. Okay. Before starting the textbook definition, let me give some examples. Okay. Here we know that in arithmetic there are basically four properties. Okay, basically four operations: addition, subtraction, multiplication, and division. Okay. Now I have here described some sets, and we will watch that which of the properties are available in which of the sets. Okay. So let's see. First set of integers. Addition, subtraction, and multiplication are available. That is, if you take two integer, you will subtract them, you will get another integer. Okay. But is division applicable here? No. For example, if 2 is divided by 3, then 2 by 3 does not. This is a fraction basically. This does not belong to the set of integers. Right? Now, set of rational numbers. Here, four operations you can be done, right? If, for example, if you took two rational numbers, then their division will also be a rational number. Okay. Now, set of all 2 cross 3 matrices. Here, you cannot multiply two matrices of order 2 cross 3. Why? Because we know that if the number of columns of a matrix, for example, AB, here, if the number of columns of a matrix and suppose this is m cross n and this is m1 cross n2, suppose. If the number of columns of A and number of rows of the matrix B are not same, then we cannot multiply them. So here, the set of all 2 cross 3 matrices, you cannot multiply them because another one, first one's column is 2, 3 and second one's row is 2. So we cannot multiply them. So this multiplication and division are not applicable here. Okay. Now, the set of all polynomials over the real number. Well, if you add two polynomial, you will get another polynomial. If you subtract two polynomial, you will get another polynomial. But is multiplication is also applicable. But the question is division applicable here? Okay, let's see. If you take 2x plus 1 divided by 3x square plus 5x plus 4. This is not a polynomial. So, division is not applicable here. Okay. So, we have seen that in arithmetic there are 4 operations, right? But in abstract algebra there will be only 2 operations. Okay. For example, 2. In arithmetic we say that 2 minus 5, right? This is subtraction. Now, how we will see it in algebra? Okay. In algebra, we will see 2 plus abstract algebra, 2 plus minus 5. That is, now here the question is, what is the minus 5? That is, we add 2 with the negative of 5, right? For example, if you take 5 minus 5 equals to 0. So here, minus 5 is the inverse of 5. We will use the term inverse of 5. Hence, there are only 2 operations defined. One is addition and another one is multiplication. So, in arithmetic there are basically 4 operations. But we will see that in abstract algebra there will be only 2 operations. One is addition and another one will be multiplication. Okay. So, why? We will watch that. For example, here in set of integers, how we define subtraction, that is 2 minus 5, right? But in abstract algebra, we will write it 2 plus minus 5. And so what is the term minus 5 here, right? That is 5 minus 5 equals to 0. So we will say that minus 5 is the inverse of 5. Okay? Inverse of 5. I am just giving you an idea so that you can relate. Okay, so here we will say that in abstract algebra Z class, when it is a group, that additive inverse of 5, right? Additive inverse of 5. Similarly, division, for example, if we are talking about the group Q, right? Or if we talk about Q plus dot, okay? Here, how we will define division? Division, we will define that 2 by 3. In that case, it will also form a field, okay, or a ring. It will definitely form a ring. So 2 by 3. Here 2 divided by 3. Here 2 is here, as there is no division, then how we will define it? We will say that 2 into 1 by 3. That is, this is multiplicative inverse of 3. Okay. So basically inverse, additive inverse. That's why in abstract algebra there are two terms. That is additive inverse and multiplicative inverse. We will define minus 5 as additive inverse of 5, and we will define 3 as multiplicative inverse of 3. Okay. So now the question is why? Why we are doing this addition and multiplication and additive inverse and multiplication inverse? Because in group, you can, for example, if I take the example group, it will be easy for you. In group, there are not only elements in set, right? Or set of integers. There are many more groups. For example, there are permutation groups. There are many more groups. What? There are 4 examples. Set of integers, set of rational numbers, set of 2 cross 3 matrices, and polynomials. Okay. So we have seen that set of integers, for set of integers, addition, subtraction and multiplication is defined. Okay, that is, if we take 2 integers, their multiplication will be also an integer. So this set of integers, we have already read the definition of groups, and this set of integers form a group with respect to addition, right? And with respect to multiplication, it is closed, right? But it does not form a group because inverse does not exist. This also true for set of polynomials, right? That this forms a group with respect to addition, and with respect to multiplication it is closed. Okay. So, and set of rational numbers, it satisfies all the 4 properties. Okay. It has all the arithmetic operations 4. Okay. So we need some name to give this structure, right? Which forms a group with respect to addition, and with respect to multiplication it is closed. Okay. So we give name to this structure, and the name of this structure is ring. Okay, now we are ready to read the textbook definition of ring theory. Okay, let's start. A ring is a set with 2 operations, plus and multiplication, if for all x, y belongs to R, x plus y belongs to R, and x dot y belongs to R. Right? And so basically these are the 2 operations with 2 binary operations. Okay. Now with respect to the addition, this will form a abelian group. This will form a abelian group with respect to addition. And what about with respect to multiplication? With respect to multiplication, this is closed with respect to multiplication. Apart from that, this will satisfy associative property. Okay, A dot B dot C for all A comma B comma C belongs to R. Now, and it will also satisfy distributive law. Distributive law. What is that? That is A dot B plus C equals to A dot B plus A dot C, and A plus B dot C equals to A dot C plus B dot C. Okay. So this will satisfy this distributive law, and this will also satisfy the multiplication. Okay. So if a structure R plus dot, this forms a abelian group with respect to addition, with respect to multiplication this satisfies these properties, then we will say that this structure is called a ring. Okay. Now this structure will call it ring. Now there are, in order to form a abelian group, or in order to form a group with respect to multiplication, there are some extra conditions, right, needed. Extra condition that is not required to be a ring. What are those extra conditions? Can you tell me? Yes, one extra condition is 1 dot u equals to u for all u belongs to R, and another extra condition is u dot v equals to 1 for all u v belongs to R. These two properties not required to form a ring. But if a ring has this property, then we will say that this is a ring with unity, right? If this identity belongs to that ring, we will say that this is a ring with unity, and this element, that is for any non-zero here u v not equals to 0. For any non-zero u, here you can see one thing that I have said that division will satisfy, but the condition is that for any non-zero element, right? For any non-zero element. So for any non-zero element u, if there exists a non-zero v such that u dot v equals to 1, then this element will say to be a unit. Okay. If inverse exists of our element, then we will say that this is the unit of the ring of that element. Okay. Unit of the element. Okay. So this is basically the definition of ring, and these are two conditions. If this exists, then we say that this is a ring with unity, and if one more condition, it is commutative with respect to multiplication. It is commutative with respect to addition, but not commutative with respect to multiplication. If it is commutative, then we will say that it is a commutative ring. Okay. So basically these are the examples. Now tell me what in this example which will be form a ring and which does not form a ring. Tell me. Question is, does Z plus dot form a ring? Observe it. Yes, this will definitely form a ring, right? Now the question is, does M2 cross 3 form a ring? M2 cross 3 form a ring. Tell me, is this form a ring? No, because multiplication, it is not closed with respect to multiplication, right? Now the question is, does R of x form a ring? Set of all polynomials over R? Yes, they definitely form a ring, because inverse नहीं है तो क्या हुआ, इसके unit element नहीं है, but they do form a ring, right? Now think about an example of a ring which is without unity. I will not tell, it's your task. Think about it. Okay. So this was basically the definition of ring theory. Now I will go to the problem of Dummit and Foote. Okay. Before going to the problem, let me give you one more definition. That is, actually here you have learned the definition of rings, right? Now what about this? This has one extra property, that is inverses also exist. Okay. So division ring, division ring, division ring. Let R be a commutative ring with unity. Sorry, let R be a ring with unity. Let R be a ring with unity. If for every non-zero, for every a not equals to 0, there exists b not equals to 0 in R such that a dot b equals to 1R, where 1 is the identity element, then R is division ring. ये मैं नहीं लिख रही, आप लोग लिख लेना. Okay, so what is the basically definition of division ring? That let R be a ring with unity, and if every non-zero element has an inverse, then we will say that this is a division ring. Here, for the rational numbers, every non-zero element has an inverse. As I have said, the division matlab inverse, right? Multiplicative inverse. Every non-zero element has an inverse, means multiplicative inverse. Ring पे तो additive inverse होते ही है, so that will be called division ring, and a commutative division ring is called a field. Okay. So these were the some basic examples, basic definitions with examples. Now we are ready to solve problem. Okay. The first problem. First problem is question number 23. Basically, this is a very nice problem. Question number 23. If you only know the definition, then you can solve this problem. Okay. So they said that P of x with respect to addition and multiplication Does this form a ring? Okay, so what is the addition here? Here the addition is A union B minus A intersection B. Okay, you can write it in another form, A minus B union B minus A. This is basically the question, and A B equals to A intersection B. This question is in section 7.1. फर्स्ट जो क्वेश्चन फर्स्ट जो एक्सरसाइज का सेट है उसपे, एंड दे आस्क दैट प्रूव दैट दिस फॉर्म्स ए रिंग, दिस रिंग हैज आइडेंटिटी एंड दिस इज कम्यूटेटिव. ओके, तो देखिए, आई थिंक विथ रेस्पेक्ट टू एडिशन यू कैन क्लियरली वॉच दैट दिस इज ए abelian group, right? Ring form करने के लिए with respect to addition it must be abelian group and it has to be closed, right? With respect to multiplication. अब देखिए, with respect to addition, basically if you take two sets, subsets of x, they are basically subsets of x, then this set will also be a subset of x, right? Now associativity is very easy. What about identity? Identity, I am giving you some idea. Think about A plus phi. A union phi minus A intersection phi. You will clearly watch that this is A. So phi is the identity element. Okay. Now what will be the inverse element with respect to addition? I am doing it with respect to addition. What will be the inverse element? Inverse element will be A plus A equals to, देखिए, A intersection A means A and this is A. So yes, A subtract, that will be phi set. Okay. So basically this is the additive inverse of A. That is, each element is its own inverse. यहाँ से एक चीज आपको समझ में आ जाया होगा कि दिस इज ए ग्रुप एक कुछ ऐसा है कि इसकी हर एक एलिमेंट का ऑर्डर 2 है. ओके, उसका जरूरत नहीं है यहाँ पर, बट आई एम टेलिंग यू. सो बेसिकली दिस फॉर्म्स अ ग्रुप. ओके, एंड दिस डेफिनेटली विल फॉर्म अ abelian group because A plus B लीजिए और B plus A, it's same. So this will form a abelian group. Now does this close with respect to multiplication? Well, definitely it is closed because this is the intersection of two sets. Suppose A is a subset of X, A and B both are subsets of X, that imply A intersection B will also subset of X. So definitely this is A intersection B will also subset of X. So definitely this forms a ring. Now the question is, what is the identity element? Okay, what is the identity element of this ring? Now देखिए, identity element means identity with respect to multiplication. तो यहाँ पर आप थोड़ा सोचिए कि A के साथ कौन से एलिमेंट लिया जाए. That will A intersection क्या होगा कि A ही आएगा. थोड़ा सोचिए. चलिए मैं बोल देती हूँ A, what about X? अगर मैं होल सेट को ही ले लेती हूँ, ओके, इट इज पावर सेट ऑफ X, बट अगर मैं X को ही ले लेती हूँ, A इंटरसेक्शन X इक्वल्स टू A. सो मल्टीप्लिकेटिव आइडेंटिटी क्या होगा? X होगा. ओके, इट्स सिंपल. नाउ सो दिस फॉर्म्स अ रिंग. और जो डिस्ट्रीब्यूटिव लॉ है वो चेक कर लेना, दैट्स वेरी इजी. डिस्ट्रीब्यूटिव लॉ कैसे मैंने कहा था, दैट A डॉट B प्लस C. ओके, इसको देख लेना, और A प्लस B डॉट C, इसको भी चेक कर लेना. ओके, एंड यू विल क्लियरली शो दैट दिस इज ए ring. ओके, वो आपका टास्क है. और नाउ द नेक्स्ट क्वेश्चन इज प्रूव दैट दिस रिंग इज अ बुलियन रिंग. इज दिस अ बुलियन रिंग? बताइए, इज दिस फॉर्म्स अ बुलियन रिंग? क्या लगता है आपको? The answer is yes, this is a Boolean ring. तो पहले तो क्वेश्चन ये है कि हमें Boolean ring की डेफिनेशन ही नहीं पता, तो हम क्या करेंगे? डेफिनेशन नहीं पता तो कैसे प्रूफ करेंगे, राइट? तो चलिए देखते हैं. Let R plus dot be a ring. Okay, if x square equals to x for all x belongs to R, then R is Boolean ring. Then R is Boolean ring. So here A square means A intersection A equals to A. Okay, so clearly A square equals to A for all A belongs to R, hence this is a Boolean ring. Okay friends, तो आज के लिए इतना ही. मिलते हैं नेक्स्ट वीडियोस पे, वहां पर मैं और कुछ प्रॉब्लम की सोल्यूशन और कुछ कंसेप्चुअल आइडियाज लेके आऊंगी. ओके, ये न्यू कंटेंट आपको कैसा लगा मुझे बताना कमेंट सेक्शन पे. इफ यू रियली लाइक द वीडियो देन प्लीज डोंट फॉरगेट टू लाइक, शेयर एंड सब्सक्राइब द चैनल. ओके, so we will meet in the new video. Meet in the new video. Take care and thank you so much. Thank you for watching the video.